Hello everybody and welcome to our third lesson in Unit 2, Absolute Value Functions and Piecewise Functions. Today's objective is we will be able to solve absolute value equations and inequalities graphically. So let's look at our first example. We have the absolute value equation, the absolute value of x plus 2 is equal to 6, and we want to graph it. The way we're going to do this is we're going to look at both sides of the equations separately and graph them as if they were separate equations. Let's look at the left side, the absolute value of x plus 2. From our first lesson, we know that this means that the vertex of this function is at -2. Remember, we switch the sign of the number that's inside of the absolute value bars. -2 and 0, and the dilation is 1. So this is the graph of this absolute value function. Now let's look at the right side of the equation, and that's pretty easy because it's just the constant 6. Let's graph the constant 6 as a horizontal line going through the point y is equal to 6. And here now we have 2 points of intersection. One is right here, and the other one is right here. So looking at the x-coordinates of those 2 points, we know that the solutions are x is positive 4 and -8. Let's move to our next example. This absolute value equation states the absolute value of x plus 2 plus 1 is equal to -2x. Now there are 2 ways we could solve this. We could move our 1 to the other side by subtracting it and then graph both sides, or we can just take the entire left side as an absolute value function with the transformations that you have learned in our first unit and graph it like that. Let's go ahead and do this. So our vertex of this function is at -2, +1. The dilation is again 1. In other words, no change compared to our parent function. And this is what the graph of this absolute value function looks like. Looking at the right side of the equal sign, -2x is a linear function of the kind that you have known for a long time. We have an x-intercept and y-intercept of 0. The slope is -2. Going back, we're also going to mark some points by going 1 to the left and 2 up. And this is the graph of our right side of the equation. The point where these two intersect is right here. And if you look at those arrows, the 3 arrows that go towards the top, you can see that the 2 red arrows go further away, one to the right and one to the left, than the blue arrow. And that indicates to us that there will be no other point of intersection between these 2 lines. This means that our solution, our only solution, is x is equal to -1. Now, when we solve this equation algebraically, and we will be solving the exact same equation algebraically in the next lesson, you will find 2 solutions, and we will talk about that because one of them is called an extraneous solution. extraneous solutions are solutions that make no sense, that we cannot find on the graph. The one we find, the only one that really counts, is x is equal to -1. The way we just solved these last two equations graphically is exactly the same as we would solve a system of equations graphically, and this is something that you have already done in Algebra 1. So now let's move on to inequalities. The absolute value of x minus 2 is greater than or equal to 3. So again, we're going to graph both parts separately and then worry about the rest. Our vertex of our absolute value portion is at +2, 0. Dilution is 1. Means we go 1 up, 1 to the right for each of the points that we need. And here is our graph for the absolute value function. Let's look at our right side. 3, in other words, just the constant, the horizontal line crossing the y-axis at 3. Now this is an inequality, and it said that the red portion has to be greater or equal to 3. So let's mark the parts where the red portion is actually greater or equal to 3. And if we then think about the x values for which this is true, we can now state that the solution set is x such that x is less than or equal to -1, or x is greater than or equal to +5. This is our solution set for this inequality. If we wanted to show the solution set on a number line, we would take our two borders, -1. Let me just make a 0 in here, and +5. We have less than or equal to and greater than or equal to. That means we use closed circles. Our arrow goes to the left on this side, all numbers that are less than or equal to -1. And we also have all the numbers that are greater than or equal to +5. And let's look at our next example. Again, we could solve this by first making a little change, moving the 2 to the other side by adding it, but we can equally just go ahead and graph right away. Our left section is an absolute value function where the vertex is at -3 and -2. Dilation is 1. Here is the curve for this part. The right side, again, conveniently, a constant horizontal line going to +3. And now let's look at the actual solution set. The red portion is now supposed to be less than the blue portion. Where is that the case? In this entire part. And also notice that we have an inequality symbol of less than, no equal to. Therefore, our solution set will be x such that -8 is less than x is less than +2. On a number line, we would graph it like this. -8, putting in the 0 just for orientation. we have an open circle as -8. -8 is not part of the solution set, but from there we go all numbers that are greater than that up to, but not including, another open circle, the number +2. All right, very good. Make sure you have the notes completed and then move on towards the second part of this tutorial.